Hi everybody. Today we're going to talk about section 2.3, which deals with the product and quotient rules and also with higher order derivatives. We're going to jump straight into the product rule, which states that in order to differentiate a product of two functions, we need to follow this rule. The first function times the derivative of the second function plus the second function times the derivative of the first. Technically speaking, this is what it is represented by. Now, not every product needs the product rule. Technically speaking, y equals 2 times x squared is a product. But because 2 is simply a coefficient of x squared, we do not need to use the product rule. Our next example is going to be an application of the product rule. Our first example asks us to find the derivative of the following function. Y is equal to x squared plus 1 times the quantity x cubed minus 5. Clearly, this is not a situation where we have a coefficient in front of a variable. This is going to need the product rule. We are multiplying two quantities together. So we're going to apply our product rule, which states that y prime is equal to the first function, which is x squared plus 1, times the derivative of the second, which would be 3x squared according to our power rule, plus the second function, x cubed minus 5, times the derivative of the first, which would be 2x. Now we need to clean things up, multiply through, and see if we can combine like terms if possible. So we need to distribute the 3x squared from the back end here. So we have y prime is equal to 3x to the fourth plus 3x squared. We also need to distribute the 2x from the back. So we have plus 2x to the fourth minus 10x. We do have some like terms here that we can combine. Positive 3x to the fourth and a positive 2x to the fourth. So our y prime, our derivative, is equal to 5x to the fourth plus 3x squared minus 10x. We must have our answer in standard form. Our next example says to find the derivative of the following function, y equals 2x cosine x minus 2 sine x. You'll see that right here we have an actual product between two functions, 2x and cosine x. This piece simply is 2 times sine x, where 2 is the coefficient of sine x. So we don't have to apply the product rule there, but for here we must. So let's go about and do the problem applying our product rule. So y prime equals the first, this would be our first function, this would be our second function when applying the product rule. Whoops, a different color here. Y prime is equal to the first, 2x, times the derivative of the second. Derivative of cosine x is negative sine x, plus the second, which is cosine x, times the derivative of the first function, which is simply 2. That completes our product rule. So now we took the derivative of the first piece. We know that we can split derivatives apart whenever we see a plus or minus like we do here. So then we simply subtract the derivative of 2 sine x. The derivative of sine x is cosine x, so the derivative of 2 sine x is going to be 2 cosine x. So now we need to clean this up. Y prime is equal to 2x, negative 2x sine x plus 2 cosine x minus 2 cosine x. You'll see that we have a positive 2 cosine x and a negative 2 cosine x. So our derivative, y prime, is simply equal to negative 2x sine x. For the first part, we needed to apply the product rule, but for the second part, the minus 2 sine x, we did not. In order to approach derivatives of quotients, we need to apply the quotient rule. So here's what our quotient rule looks like, which it looks a little more complicated than it is. What we can do is we have a nice little catchphrase that we can use in order to help us remember how to differentiate quotients. What we can do is we call the numerator the high, the denominator the low. And then we go with the phrase, low d high, less high d low, all over denominator squared we go. When I first heard this, I thought it was silly, but in all honesty, I've been using it ever since. Now, low means you take the low function. D high means the derivative of the numerator. Less means subtract the high function times the derivative of the low function, the derivative of the denominator, all over the denominator squared. Let's jump straight into our first example to see how the quotient rule works. So, we have y prime is equal to low d high, which means take the low, the denominator, x squared plus 1, times the derivative of the high, which is just 2x, the derivative of our numerator, less, subtract, high, our numerator, x squared minus 1, d low, which is the derivative of the denominator, which is just 2x, all over denominator squared we go. Now let's clean it up. When I distribute in the back end here, we have y prime, our derivative, is equal to 2x cubed plus 2x minus, this is where students make mistakes, it's minus the product of this. So we have minus the quantity 2x cubed minus 2x. Oops, bracket. All over denominator squared we go. When I distribute my negative into this quantity, I have y prime is equal to 2x cubed plus 2x minus 2x cubed plus 2x all over x squared plus 1 quantity squared. You'll see our 2x cubes cancel each other out, and we are left with y prime is equal to 4x over the quantity x squared plus 1 squared. That is our answer. You'll notice that I did not FOIL out my denominator because it wasn't going to get me anywhere anyway. Sometimes you'll be able to cancel with factors. However, again, like I said, it doesn't get us anywhere. Just clean up your numerator and see if you can do any algebra from there. So here's our answer. Now let's apply our quotient rule with trig. Find the derivative of the function f of x is equal to cosine x over x. So f prime of x is equal to low d high less high d low all over denominator squared we go. So low x times d high, the derivative of the numerator, which is negative sine x, less, subtract, high d low, so the numerator times the denominator's derivative, all over denominator squared we go. Let's clean it up a little bit. F prime of x is equal to negative x sine x minus cosine x all over x squared. No, we cannot cancel out the x's because in our numerator we do not have factors. So here is our derivative. As we saw with products, not every product requires the use of the product rule. Same holds true for the quotient rule. Not every quotient has to be evaluated by the quotient rule. Looking at our first function, y equals x squared plus 3x over 6, we can rewrite that by putting the 6 in the denominator with each piece of our numerator. So we could rewrite that as y equals 1/6 x squared plus 3/6 x, which would be 1/2 x. If I differentiate that, I then have y prime equals 2/6 x plus 1/2. And then I clean that up by y prime equals 1/3 x, or x over 3, whichever you prefer, plus 1/2. Let's check out b. Let's first start by distributing our -3 into our numerator. Then we'll do the same thing we did in part A. So let's start down here. Y is equal to -9x plus 6x squared. And I'll separate the over 7x and put it into both pieces right away, make our life a little bit easier. So we can cancel out our x's. Simplify, this becomes x to the first. So our rewritten function is y equals -9/7 plus 6/7 x. If I differentiate that, the derivative of a constant like -9/7 is equal to 0, and the derivative of 6/7 x is simply 6/7. No need to simplify here. Y prime is equal to 6/7. Here's our next example, which is asking us to take it a little bit farther. It says find an equation of the tangent line to the graph of f at the indicated point. So if we're finding an equation, we need a point, which we do have, and we need the slope. In order to find the slope of a tangent line, we know that we need to find the derivative. In order to calculate this derivative, we need to use our product rule. So let's get started. F prime of x is equal to the first. Okay, here's our first function, and here's our second function. Okay, so it's equal to the first, x squared plus 2x plus 3, times the derivative of the second, which is 3x squared minus 8x plus 6, plus the second, x cubed minus 4x squared plus 6x plus 1, times the derivative of the first, which is 2x plus 2. Now we can either do a lot of work to clean up this derivative, or know that all we have to do with the derivative is plug in 1 for x in order to find our slope. Okay, so let's just do that, because then we don't have to multiply out a trinomial times a trinomial and a polynomial times a binomial. So let's just plug in our 1 for x and eliminate all of that work, because we don't really care what the simplified version of the derivative of our function is. We just want to find the slope when x is 1. So let's plug in 1 for x. F prime of x is equal to 1 squared, which is 1, plus 2 times 1, which is 2, plus 3, times 3 times 1 squared, which is 3, minus 8 times 1, which is 8, plus 6, plus 1 cubed is 1, minus 4 times 1 squared, which is 4, plus 6 times 1, which is 6, plus 1, times the quantity 2 times 1, which is 2, plus 2. There's a higher probability of getting this correct plugging in your 1 right from the start as opposed to multiplying everything out. So let's clean up inside of our parentheses. So we have f prime of x is equal to 1 plus 2 is 3 plus 3 is 6. So we have 6 times 3 minus 8 is negative 5 plus 6 is positive 1 plus 1 minus 4 gives us negative 3 plus 6 is positive 3 plus 1 is 4 times 2 plus 2 is 4. F prime of x is actually f prime of 1 is equal to 6 times 1 is 6 plus 4 times 4 is 16. So f prime of 1 is equal to 20. Oops, what happened to my pen here? Is equal to 22. So this is my slope. I now have my slope and I have my point up here. So we can use our point slope form, which says y minus y1 equals m times x minus x1. So we have y minus 24 is equal to 22 times x minus 1. And there is our equation of the tangent line to the graph of our function at the ordered pair 124. Our next example asks us to find an equation of the tangent line to the graph of f at the indicated point, and we have the function f of x is equal to x cubed plus 3x plus 2 over x squared minus 1, and our point is 0, negative 2. In order to find the equation of the tangent line, I need to find the slope of the tangent line when x is equal to 0. In order to find the slope of a tangent line, I need to find the derivative. In order to find this derivative, we need to apply the quotient rule. So let's get started. F prime of x is equal to low d high, so x squared minus 1 times the derivative of the numerator, which is 3x squared plus 3, less high, x cubed plus 3x plus 2, d low, the derivative of our denominator, which is 2x, all over denominator squared we go. Just like we did in the last problem, because we only need the derivative to find the slope of our tangent line when x is equal to 0, we don't need to simplify and risk making any mistakes with the algebra. So let's just plug in x equals 0. So to find our slope, when x is 0, we have f prime of 0. Let's plug in 0 for x. Well, when I plug in 0 for x here, we end up with a negative 1 times 3 times x squared, that's going to be 0, so negative 1 times 3, minus, when I plug in 0, that becomes 0, this becomes 0, so we have 2 times, when I plug in 0 here, I get 2 times 0 is 0. All over my denominator, 0 squared is 0, so I have negative 1 quantity squared. As I clean this up, f prime of 0 is equal to negative 3 minus 0, which is negative 3, over positive 1. So our slope is equal to negative 3. Now we can use our point slope form to write the equation of the tangent line. So y minus y1, so we have y minus negative 2, so plus 2, equals m, negative 3, times x minus x1, which is 0. No need to have that there, so y minus 2 equals negative 3x. Or, since we're already almost there, we can also put it in slope-intercept form. Y is equal to negative 3x plus 2. I now have a little challenge for you. I'd like you to differentiate f of x is equal to 2x cubed plus 5x times the quantity x minus 2 times the quantity x plus 3. Come in tomorrow with your answers and we will compare notes.